And so what happens is, I'll give you an example. If you take the DSM, it's possible to have both two people to have depression. One of them is suicidal, crying, feels guilty about everything in life. And the other one has no energy, nothing makes them feel good, and they have trouble concentrating and sleeping. Those sound like entirely different problems, right? But they technically both meet the same diagnosis. And the problem is that because there's so much overlap between these different things, it's hard to use clinical criteria to set it up.
And they essentially get treated the same way, right?
Correct.
Like literally with treatment, you know?
Well, the point is, this is the equivalent of putting a cast on everyone's right arm because that helps sometimes, right?
Yeah.
Well, everyone else with a different broken bone is not getting the right treatment, and it doesn't work. And this is why they have a 40% success rate, right? It's pretty good. That's better than zero. And remember before then they were doing frontal lobotomies and ECT, right, for everything. So ultimately, what the problem though is that when you get down to it, we do not have enough people to handle the mental health crisis the way we're doing. It's not possible. And part of the reason is if a psychiatrist sees a patient, they have to take a history. 25 minutes is efficient. Then they've got to convince the patient a lot of times that they have the problem that they think they do and build a relationship. That could take a long time, even years. And people personality disorders never agree that they have them. And then you start the therapy if you start it, right? And this is the same whether you're doing CBT, whatever you're doing. And so you have to do that over and over and over again on a problem of that's 25, 30% of the population with a field that only has a ratio of psychiatrists to general practitioners or people with mental illness of like 8,000 to 1. That's just not doable, right? So what ends up happening is we have family medicine, but even that, if you're doing something inefficiently because you don't have objective tests to shortcut some of this stuff and just get to the point. This would be like me sitting there trying a long discussion with you to try to figure out what your blood sugar is and diagnose you with diabetes. That's really inefficient compared to just sticking the finger. So ultimately, people are trying to scale this with tech. But of course, one of the things is chatbots can obviously have the challenges we see with AI. But the reality is you still have a manpower limitation, right? And you still have that. So one of the things we started working on is, how do we think about the problem differently? And the best way to improve efficiency isn't to organize the problem a different way. It's to actually change the problem. And so what we know, for example, if you look at the upper left, is that different parts of the brain that are not next to each other fire in sync for periods of time. They're not exactly synchronized, but they're very close. And we can quantify. If you look in the middle, this is our pipeline that can actually measure every single connection and every single correlation between two areas. And what happens is, this is the process of mapping a connectome. So you look at areas and different parts of the brain are firing at different time points to cover different cognitive functions. What happens is that if you and I are laying in a scanner, assuming neither one of us have a disease or a mental illness, there's certain things that are going to be different because you're thinking about your podcast and I'm thinking about baseball or whatever. But there's certain things that are very consistent. Like the motor system and the visual system talk amongst themselves very often. And mentally ill people have things that happen in their connectome that don't happen in normal people. They're just things that are too correlated or not correlated. And if you map that for the whole brain, you find very complicated patterns. But using AI, you can actually start to make sense of it. And so the NIMH started to take the field into this area of saying, listen, let's not put labels on it. Let's just say that there are normal functions like the reward system. So something good happens, you feel good about it. Or a system that called reward effort. When you predict how likely is something good going to happen and how much work is it going to take and how much work am I willing to do it? Well, if that system is off, no matter how good it is, you're not going to do it because you don't have motivation. And that's a common problem in depression and other diseases. But you can also have it through schizophrenia. You can have it through head injury. And that's called the transdiagnostic approach, where we don't try to make a diagnosis. We just talk about the circuits and we focus on the circuits. What we basically built is a concept that says we can start to take the symptoms and figure out what circuits are the likely culprits. Because we now start to know where in the brain these things happen from lots of research. And why that's revolutionary is, right now what we do is we say, well, hey, these people have these things in common, so they all have the same diagnosis. But then the problem is there's a lot of things that they don't have in common. And it's almost an infinitely complex problem. And we're asking psychiatrists to solve this problem without any objective tests. And so what we started doing is saying, let's just look at the circuits. Let's look at how they talk to each other, because we know who the circuits are. We've mapped a lot of these. And we can start to look at areas that are firing out of sync and quantify them. And what we get is we get a test that basically looks at the patient's circuits and says, well, you said you have this, and you do or do not have an actual problem with that circuit. And then we can begin to do therapy based on it. Now, obviously, we can think about more complicated things like stimulation and things. But ultimately, the first thing it does, if you look in this one, the left is what you see in a normal person in the fear circuit. Now you see the fear circuit's complicated; it's a lot of parts, but the flag colors, the white ones are areas that are basically behaving normally, and the flag colors are outliers. On a normal person, you might see a few, but that person on the right was literally having a panic attack in the scanner. And you can see that the circuit has gone nuts. There's lots of abnormality in that particular time. But what if that's your circuit all the time? Well, you're prone to having panic attacks, right? Anything can trigger it. And that's the problem. Well, one, you could put electrodes, brain machine interface. We could think of drugs. There's different ways you can try to normalize a circuit. But the simplest one is CBT works if you are actually aiming it at the right problem. And there's 100 different ways to do therapy. So what we can do is we can take ChatGPT, take all the circuits you have, we make a modified version of it, and then we can basically design a therapy plan that actually hits all of the circuits that are actually wrong in them. We don't even need to know what their diagnosis is. It's irrelevant. We'll just go straight to the circuits.
Interesting.
And so what you can imagine is what happens is, instead of having this long discussion, we just go straight to the test. We have you take a survey. We make a bunch of therapies that are aimed at reward prediction circuits. And there's a circuit called reward satiation, when it says you've had enough. Well, when that doesn't work, you either overeat or you binge and purge. That's bulimia. That's one of the core problems. Or you get prone to doing too much drinking or drugs. It's part of a lot of diseases, right? And this is why a lot of people who have mental illnesses have drug problems. It's the same thing. It's ultimately the circuits. So what we do is we design a therapy using generative AI that makes a novel therapy. And that lets you go a lot faster because you get to the point quicker. And that lets you work with people who are not necessarily board certified psychiatrists, because we have to extend and let them behave as super psychiatrists. But ultimately, when you get down to it, is the core thesis is that if you're smarter, you work faster and do better care. So that doesn't matter what disease you're treating. And so we've made models. We have about 120,000 brain with data on who these patients are, whether that got better or not, et cetera. And what we've been trying to do is just turn it into tools that actually solve a problem that actually improves